Thank you so much for joining this lesson. We shall discuss the Alliance Mathematics Forum Examinations 2025. This time around, we're going to look at the July mock, Mathematics Paper 2, Section 1. Then later, we shall be discussing the Section 2. So as we go through this paper, it's good for me to bring to you our program here, whereby over the August holiday, we shall be discussing serious mathematics, physics, chemistry, biology, Kiswahili, and English through Google Meet. So we invite you to enroll. Consider to call my number or to chat in WhatsApp, most preferably 0704 15 3366. So reach out to us and get to know more about our program. Invite a candidate, invite a friend in high school so that we may grow together. We also have our platform here whereby you can purchase airtime of any amount to any network by simply going to the M-Pesa, Lipa na M-Pesa option, then the pay bill now. Our pay bill number is displayed here, 737356. Then the account number is the phone number that you intend to purchase airtime for. This could be your Airtel line, your Safaricom line, or your telecom line. You can also invite a friend to the same. You can also use the same pay bill and the account number of a friend so that you may buy airtime for them. So welcome and utilize our platform. Back to the paper. The roots of a quadratic equation are -3 and -1/6. That's -2/3 and -1/6. Form the quadratic equation in the form ax squared plus bx plus c equals to 0, where a, b, and c are integers for 3 marks. So let's look at this one now. We're going to use the factorization method to ensure that we come up with these. So what we're supposed to do is to ensure that if x is equivalent to -2/3, this implies that then x plus 2/3 is equal to 0. And from the other root, which says that x is equal to -1/6, this implies that x plus 1/6 equals to 0. So now we have the two factors already for the quadratic equation. And therefore, from this, we can now say that x plus 2/3 into brackets x plus 1/6 is equal to 0. We're just using the reverse process of factorization method. Before x equals to -2/3, it means we add x plus 2/3 equal to 0, or x equals to -1/6 equals to x plus 1/6 equals to 0. Then now, before we had that conclusion, it means we had the two factors multiplied, then equated to 0. So from this now, it means this was a simplification. So we can now expand. The equation had been factorized to give us this. Now to get back to the equation, we have to expand. So we start by x multiplying everything in the second bracket. So x should multiply x plus 1/6, then plus 2/3 should also multiply everything in the second bracket equals to 0. So we can now open these brackets and have x squared plus 1/6 x plus 2/3 x plus 2 out of 18. Yeah, 2 out of 18. We can simplify at a different stage because I know that one can be simplified to 1/9. Then after that simplification now, we can group terms. So at this point, allow me to to now group terms and simplify where possible. So at this point now, I'm going to say x squared 1/6 and 2/3. They are both like terms, so they can be added to 5/6x. Then this is 1/9 after simplification equals to 0. So at this point again, we can now multiply through by LCM because we are to do away with the denominators because we are told to ensure that the equation is left in the form displayed there, whereby all the constants are integers. For your information, we are already having the equation, but now we have to obey the instructions of ensuring that we have integers and not fractions. Therefore, allow me to talk about the LCM of 6 and 9, whereby if I factorize this, I can start by 2 to get 3, to 9 remain that way. By 3, 1 and 3, then by 3 once again, 1, 1. So now we shall be having 18 as the LCM. So I'm supposed to multiply every factor here by 18. That way, I shall have done away with the fractions. Therefore, by 18, this becomes 18 x squared plus 5/6x by 18. 6 will cancel to give us 3. Then that becomes 15x. By 18, this becomes 2 equals to 0. Now we have the final stage of the equation, and it is in the format which the examiner is demanding. So that's how we are supposed to ensure that we have arranged our equation. Let's check number 2 together. Ladies and gentlemen, remember to subscribe, remember to comment, remember to share with a friend so that we keep shifting grades growing. The home science teacher in a school intended to subdivide a piece of material into 9 parts for our students. She approximated 1/9 meters to 0.111 meters. It's supposed to be meters, I think, same units. Calculate the percentage error in the approximation. First, we are supposed to check the error. What is the error in this approximation? What is the error? The error is usually given by actual value minus approximated value. The approximate or the estimate. Then we take the absolute value of that. So let's get the error. The error shall be 1/9 minus 0.111. Now this is going to give us 1 out of 9,000. So now we are having the error. And simply, the error is usually the difference between actual value and the estimated value. We advocate for the absolute value because some other times the approximated value can be greater than the actual. So in such a case, you are advised to take absolute value. All right, so now when we talk about percentage error, then we are supposed to take the error out of actual value. Then we express it as a percentage by multiplying with 100. So 1/9,000. This divided by the actual value, which is 1/9. Then this should multiply by 100. And from this, we should get 0.1% error. So the percentage error in the estimation of the home science teacher in this certain school is 0.1%. Yeah. Thank you so much, ladies and gentlemen, for following up with our program. Of course, the best online school, Shifting Grades. Now, number 3, solve the equation 2, the sine squared of x minus 30 degrees equals to the cosine of 300 degrees for the range negative 180 to 180 for 3 marks. So let's look at how to maneuver through this one. So to proceed with this, we're supposed to say that according to the angles greater than an acute angle, there is always the acute angle that corresponds to a given angle which is greater than 90. There is always an acute angle which is greater than 90 degrees. So for that case, I'm going to refer people to the unit circle. So the unit circle, definitely, let me just draw it. The unit circle, I draw the Cartesian plane first. Let's be keen in this one. Let's just be very keen in this one. So I'm having a Cartesian plane here. And on the Cartesian plane, ladies and gentlemen, I'm having a unit circle there. Whereby I would say an angle of 300 shall lie in the fourth quadrant. This is usually the first, the second, the third, and the fourth quadrant. So now for us to get an angle of 300 degrees, it means we are standing here, that is 90, 180, 270, then we shall add 30. That means after adding 30, we are remaining with 60 degrees at this point. Look at this now. Look at this. An angle of 300 degrees equals to 60 degrees in the fourth quadrant. 60 degrees in the fourth quadrant is equivalent to 300 degrees. So all the trigonometric ratios of an angle of 60 degrees in the fourth quadrant shall align with 300 degrees. So after knowing this, now we shall know that the cosine of 60 is usually equal to the cosine of 300 degrees. And with that knowledge now, we shall say that 2, now back to the equation, the sine squared of x minus 30. This is equivalent to the cosine of 60 degrees. Then 2, the sine squared of x minus 30 equals to, now we take the sine inverse of 60. You just go to your calculator, shift cos 60 for you to get the cos inverse. And the cosine, the value of cos 60. In other words, what is the value of cos 60? The value of cos 60 is 0.5. Cosine of 60, you just confirm it from your calculator or the mathematical table. Cosine of 60 equals to 0.5. Then from this point now, we can remain with the sine squared of x minus 30 degrees after dividing through by 2, meaning that we shall have 0.25 on our right hand side. You see? So at this point now, ladies and gentlemen, because this is sine squared of x minus 30, then we can remain with the sine of x minus 30 and take square root for both sides. Because sine squared of x minus 30 equals to 0.25. Then it means now we are taking square root. And when we take square root, ladies and gentlemen, then we shall get 0.5 plus or minus, because the square root will give us both values. So at this stage now, we can talk about these particular angles now. What is the value of x minus 30? Whereby we're supposed to take the sine inverse. Now we talk about sine inverse. If the sine of x minus 30 equals to plus or minus 0.5, then the sine inverse will give us these angles of both values. So at this point, ladies and gentlemen, and it's my hope that you've subscribed to our channel, Shifting Grids. Subscribing is free. So just subscribe to the platform and support us. Let's grow together. All right. So we shall be concluding now that from the negative value, we shall get negative 30. And another possible angle is negative 150. Then, using the positive part, where are signs positive? For positive 5, we shall talk about an angle, acute angle of 30 and 150 in the second quadrant, that way. So these are the possible angles from the two values of sine. Can we now remain with x by taking negative 30 to the right, where obviously it shall be added? Negative 30 plus 30, because it has to be added now on the other side. That becomes a 0 degrees. Then negative 30, because it has become positive, we talk about negative 150 plus 30, which is negative 120 degrees. Then we are also talking about 30 plus 30, giving us 60. And finally, 150 plus 30 giving us 180. So according to the provided range, we have sampled the possible angles. That is what I expect followers of Shifting Grids to be in a position to do. Number 4 now, a question on surds. And ladies and gentlemen, it's advisable for you to be very cooperative during our lessons, simply because the questions that we handle here are most likely to appear in the KCC. That's why I'm doing my best to get the best revision materials for this platform. So be sure that every question or every paper that we upload in this platform is very predictive and should be followed with the seriousness that it deserves. Our number remains 0704153366. Through the same number, you are free to request for revision materials, and you are also free to register for our holiday programs. Simplify as far as possible, leaving your answer in form of a surd. 1 divided by the root of 13 minus 2 root 3 minus 1 out of the root of 13 plus 2 the root of 3. So with this now, I advise my learners to treat a surd just as a normal fraction, whereby you are now supposed to take the LCM, whereby the LCM is root 13 minus 2 the root of 3 into root 13 plus 2 the root of 3, that way. Then now with this LCM, we're supposed to divide the denominators, then times the numerator. So the LCM divided by the first denominator, the part with a minus shall simplify, and we shall remain with 1 times the root of 13 plus 2 the root of 3. This one has been multiplied by 1. Then minus, we divide again. The LCM divided by the second denominator, which is having a plus. It means the part with a plus is the one now to simplify out, and we shall remain with root 13 minus 2 the root of 3, that way. So at this point now, we can first group terms from the numerator by having root 13 plus 2, the root of 3, then minus the root of 13, plus, because of negative times negative, remember we are opening the bracket there. So that now becomes positive 2, the root of 3, that way. And this should be divided by. Now, from the denominator, ladies and gentlemen, allow me now rationalize the denominator to ensure that we don't have a surd there. To rationalize the denominator, we usually have a surd multiplied by its conjugate, and automatically that is what we are having from the LCM. Now that it is a surd and its conjugate, to simplify this, we're supposed to take root 13 squared minus 2 root 3 also squared. So we need root 13 squared minus 2, the root of 3 also squared, that way. We group terms on the numerator. Root 13 minus root 13. This one and this one shall simplify. Then we shall be remaining with 2 root 3 plus 2 root 3. And that becomes 4, the root of 3, out of, we go back now to the denominator. Root 13 squared becomes 13 minus 2 root 3 squared becomes 4 times 3, because 2 squared is a 4, and root 13 squared becomes 3. So we shall be having 4 times 3, which is a 12. You see now, we'll be having 4 over the root of 3, and this is a 1. So 4 the root of 3. You see now, we are having the final answer as 4 root 3. That is how you're supposed to work out the third question. Very simple, very simple. So remember to operate a surd just as we are directing you. Can we look at number 5 now? A question on this is a question on logs. This is a question on logs. Solve for the log of x to base 3 raised to power 2 minus a half, the log of x to base 3 equals to 1.5. Yeah, equals to 1.5. This is a good question. A very good question. So allow me to do this. I can see the logarithm to the base of 3 of x. The log of x to base 3 is appearing twice. It is appearing here, raised to power 2, and it's also appearing here, multiplied by a half. So we can begin by letting the logarithm of x to base 3 be a certain unknown like t. So let's work out the value of t now, whereby we shall now have t power 2 minus half the value of t. Then this is equal to 1.5. All right, we can have it as 1.5 or 3 over 2. It's all the same. So we can multiply through by 2 to do away with fractions, or depending on the formula that we would like to solve the quadratic equation with, we can just leave it that way. For instance, if I choose to follow the completing square method, I would prefer it this way. So instead of doing away with the fraction, we can just proceed this way and solve this quadratic equation using the completing square method. So t squared minus half t, we add a constant here. Then 3 over 2, we also add the same constant there. We should look for a constant such that when this constant is added to the left-hand side, it shall become a perfect square. Look at that. It shall become a perfect square. That's why I keep telling my followers that the knowledge on quadratic equations and expressions is paramount. A very basic concept such that You might not be told to solve a quadratic equation or an expression, but look at the question. It is a logarithm question, but now we have to engage the knowledge on quadratic expressions. Therefore, I'm now going to borrow a lot from quadratic expressions. This way, I'm supposed to be aware that for an expression to be a perfect square, then the value of b, okay, the value of a constant c should be equal to b out of 2 squared. In this case, the value of a is 1. That's why we are using that method. When the value of a is 1 in a quadratic expression, which is a perfect square, the value of the constant c should be equal to b over 2 squared. Therefore, according to what we have, negative half is our b. So when we divide this by 2, then we square. What are we getting? 1 over 4 squared negative shall become 1 over 16. Yeah, 1 over 4 squared is 1 over 16. So now I'll be adding 1 over 16 and also 1 over 16 to this side. That way, I'll be talking of t squared minus half t plus 1 over 16 equivalent to, now I take 3 over 2 minus 1 over 16. This gives me 1 and 7 over 16. That way, 1 and 7 over 16. At this point now, I should be, okay, did I add really? No, sorry. 3 over 2 plus 1 over 16. Yeah, it should be addition. I'm getting 1 and 9 over 16. 1 and 9 over 16, not 7. 1 and 9 over 16. So at this point now, allow me factorize the perfect square on my left. For me to factorize, I should take the square root of the first part, which is t, the sign that follows, which is a minus, the square root of the constant, which is 1 over 4 squared, equals to, at this point, I'm having 25 over 16. So from this point now, I can take square root for both sides to remain with t minus 1 over 4 equals to plus or minus 5 over 4. Yeah, plus or minus 5 over 4. You see, now we are taking the longer time to solve a quadratic equation using the completing square method in a question which is logarithmic. Very interesting. I can utilize the space here actually to find the value of t. So to remain with t, I'm supposed to take the first part of the square root, then I add a quarter, or t equals to the second option plus a quarter. Yeah, plus a quarter that way. So from the first option, I'll be having 6 over 4, and that will give me 1.5. That will give me 1.5. So the value of t equals to 1.5, or t equals to the second option, negative 4 over 4. Negative 4 over 4, which is a negative 1. So I'm getting negative 1. So we have two possible values of t. With the two possible values of t, ladies and gentlemen, I can now talk about, you remember what we had let to be t? The logarithm of x to the base of 3, which is t now, can either be 1.5 or the log of x to base 3 equals to negative 1. At this point, we can now solve for x. We shall talk about converting a logarithm equation to index notation, whereby given the log of a to base b as c, then this implies that when we take the value of b power c, we should get a. So with this knowledge now of converting a logarithm expression to index form, we can now solve the part and say 3 power 1.5 should give us x, or 3 power negative 1 should give us x. So from the first expression, x shall be 5.196 to 4 significant figures, or the value of x equals to 3 power negative 1 becomes 1 over 3. Because according to the negative law of indices, we should make it a third and we raise it to positive 1. So a third power positive 1 will automatically give us a third. So we have it done now. Well solved. You see, they had awarded 4 marks for that because it is an involving question, bringing two concepts together. So it's a good question. You can follow through again. The good thing with our presentations is that once you want to review, you can always get back again and again. We can look at number 6 now. The figure below shows a circle and a point A outside the circle. Here we can all see point A outside the circle. Let's get now to the point A is here. I hope you can see the dot for point A, and you can see the circle at this point. So they have been presented so clearly. Then from this now, what is the demand statement from the examiner? Using a ruler and a pair of compasses only, construct 2 tangents from point A to the circle. So for us to construct 2 tangents from point A to the circle, one thing that we are supposed to be very sure about is the center of the circle. So let's identify the center of the circle first. We identify the center of the circle first. And how do we get the center of the circle? We just take any 2 chords. Any 2 chords. Let's take that one serious. Any 2 chords to the circle. Like if this, we call it a chord, and we can name it chord PQ. Then we bisect it perpendicularly. We bisect the chord perpendicularly. Again, we know that any bisector to a chord should pass through the center of a circle. We can also do another chord on the lower side. This other chord can be RS. With chord RS, we also bisect it perpendicularly. So when this chord is bisected perpendicularly, ladies and gentlemen, it is also supposed to pass through the center of the circle. And therefore, we can conclude from that the intersection of the bisectors of the chords is our center O. So now the center of the circle is identified. How do we get the center of a circle? It had just been drawn without the center indicated. That means we come up with any chords of any size. These 2 chords, and the sizes must not be the same. Chord PQ doesn't have to necessarily be equal to RS, and you can name your chords anyhow. Therefore, bisecting a chord makes you pass through the center of the circle. So you bisect the 2 chords and they shall intersect. And where they intersect, that is the center of the circle, because they are both passing through the center. So their point of intersection now helps us to conclude that that is our center. After knowing the center O for this case, now we join the external point to the center. We join point O to the center that way. So we have OA. So with OA, we are supposed to identify the middle point of OA. Yeah, the middle point. After identifying the middle point, and remember, we are not supposed to use a protractor or anything else. We just have to identify this by perpendicular bisection of the lines. So we make an arc on this part and also on the lower part, standing at O. Then we stand at A, we cut the first arcs that way. Then when we join them now, and we don't have to practically join them, we can just place the ruler very well. And now we use our pencil to mark the implied middle point X. The implied middle point X. With middle point X, the middle or the center, the midpoint of OA, with that point now, we need to stand at that point and we use an arc whose length is OX. We use an arc whose length is OX. To make an arc on both sides of the circle, let me now apply some different ink whereby I should stand at X. I'm standing at X, and the length that I'm using is OX. I hope you're mastering that procedure. I'm using my compass with an arc length OX, and I'm standing at X to make an arc on the upper part and to make an arc on the lower part that way. So now if I make those arcs, I'm supposed to join them to point A. I join them to point A. If I join them to point A, I will have obtained the desired tangents from the external point. Look at that. I've joined that point, and I also joined the other one, point S to A. Yeah, that way. So the chords that we needed, not the chords, but the tangents from an external point A have already been established. Those are the chords. These are the two tangents. Tangent 1, tangent 2. So now I have my work thoroughly done. Look at that. Thoroughly done. So that is what I expect now my followers to be in a position to do. If you're following Shifting Grades Online School, please be in a position to come up with diagrams as decent as ours. All right. Proceeding to number 7 now. Miss Beth wants to buy a flat screen television on hire purchase. The cash price is 28,000 Kenya shillings. She can pay the cash price or make a down payment of 8,000 Kenya shillings and 15 monthly installments of 2,000 each. Calculate the rate of compound interest charged per month. This is a concept which has been disturbing. Let me say that. Several learners, because from the consultations analysis, I've seen a lot of people trying to engage me on this type of a setting. It is a common setting, and we are supposed to be conversant with it. In this manner, once a down payment has been done, interest is charged on the balance. Therefore, it is the balance from the cash price after deposit has been made that becomes the principal. It is what shall earn interest. Then it will earn interest until the amount is equal to the total installments that are paid. So from that case now, allow me say this, that I should be having the balance now, which becomes principal. The balance that indirectly now becomes our principal amount, because it is what shall earn interest, shall be the cash price, 28,000, minus the deposit of 8,000 to give us a 20,000 Kenya shillings. 20,000 Kenya shillings. From this now, we can also say that there is the amount that will end up being paid. So instead of this Madam Beth to pay 20,000, she shall be paying an amount equivalent to 15 installments, each 2,000, and this gives us 30,000 Kenya shillings. So instead of the balance, which could have been 20,000, she ends up paying installments, which are now 30,000. Therefore, we shall say that the balance has earned interest. The balance has earned interest. Therefore, according to compound interest formula, amount is usually equal to the principal into 1 plus the rate of interest raised to n. N is the number of interest periods. For that case, I shall substitute whatever value that we are already having. 30,000 equals to 20,000 into 1 plus rate over 100 raised to 15. So now we can work out for the value of R by first taking 30,000 and we divide by 20,000. That gives us 1.5. 1.5 equals to 1 plus the unknown rate, which is a percentage, raised to 15. So at this point now, we can take the 15th root on both sides. So you write in your calculator 15 shift power, then you write 1.5. 15 shift power 1.5. So from this, I'm getting 1.0274 to 4 significant figures. Yeah, to 4 significant figures. And this is equivalent now to 1 plus the rate over 100. Remember, it was raised to power 15, and we have now obtained the 15th root to cancel power 15 on both sides. So at this point, allow me to say that R over 100 equals to, we subtract 1 from both sides, 0.0274. So how do I remain with R? By multiplying by 100 both sides. So this becomes 2.74%. This is now the monthly percentage rate of compound interest according to the business transaction above. So that's how we work out such a question. Well executed. Kindly follow up and understand what is happening. At number 8 now. At number 8 already. Another good question. Make K the subject of the formula. Make K the subject of the formula. One thing that we are supposed to understand in this case is that the power here, which is a fraction, or which is a decimal, can be made a fraction. That is a half. So when we have this as n out of k equals to 9 minus 1 over nk squared, this now should be known that it is raised to power half. And when we raise to power half, ladies and gentlemen, it's like we are taking the square root, because according to the fractional law of indices, for us to operate the right-hand side, we should obtain root 2, then we raise to power 1. To obtain root 2 means the square root. So now this is square root. To do away with this power, we multiply by 2. We multiply the power by 2, and also we multiply the power here also by 2. So we shall have n squared over k squared equals to, we have done away with the square root sign by squaring both sides, nk, and the k is squared. Nk squared, that way. You know, we are supposed now to ensure that the terms with k are grouped together. The terms with k are grouped together. Therefore, allow me now to talk about n squared over k squared. N squared over k squared. Then we add 1 over n k squared equals to 9. So we remain with 9 alone on the right-hand side. And on the left, what are we having? N squared over k squared. Then the negative 1 over nk squared now becomes positive to the left. That way, we can factor out 1 over k squared and remain with n squared plus 1. Let's check something here. The 1 should be over n at this point equals to 9. Yeah, equals to 9 that way. Let's proceed working out. Let me now underline here for me to proceed. Check what I have just factored out. So this means now we are supposed to divide. We are supposed to divide both sides. This is after, for us to remain with squared that way, equals to 9 should be divided by n squared plus 1 over n. Yeah, n squared plus 1 over n that way. N squared plus 1 over n. So if 1 over this, 1 over k squared equals to 9 out of all that, this is an indication that we can also take the reciprocal now on both sides. Obtaining reciprocal on both sides will give us k squared s n squared plus 1 over n divided by 9. Yeah, divided by 9. That way. Divided by 9. You see that? Divided by 9. So let's talk of now k alone. And k alone shall be the square root now. Because k squared equals 2. Then to remain with k, we obtain square root. Plus or minus. Now I take square root of, taking the square root of n squared plus 1 over n out of 9. That is now the value of k. But remember, on the denominator, the value of root 9 is known. So k equals to plus or minus the square root of n squared plus 1 over n, everything divided by 3. Everything over 3. Because the square root of 9 is already known. So that is an advanced stage of the same answer. Though the answer is usually provided at the earliest stage possible, just after you have expressed k, you are deemed to the final mark. So that is it. But remember, from again the numerator, from the numerator, we can have, from the numerator, I think we can have them under one denominator, whereby it shall be n. So we can still move further and simplify, whereby we shall be talking of k being equal to plus or minus the square root of n squared plus 1 over n that way. And we are dividing by everything by 3, which means to divide by 3, You know, dividing by 3 means multiplying by a third. Dividing by 3 means multiplying by a third. So we can have a third coming at that point. So these are all stages of the answer. And that is how you're supposed to work it out. So that's a very good question, which is really engaging the brain of a learner. As a student, are you able to make subject of a formula? Remember, we are at number 9 now. At number 9, a question from sequences and series. We are told that the first, the third, and the seventh terms of an increasing arithmetic progression are 3 consecutive terms of a geometric progression. In the first, or if the first term of the AP is 10, find the common difference of the AP and the common ratio of the GP. All right, we are told that the first term can be called A, together with the third term and the seventh terms. So the third term, according to the formula that says any of the term, when a sequence is geometric, when a sequence is arithmetic, the first sequence is arithmetic now, is given by A plus n minus 1 multiplied by the common difference. So the first term is A. The third term shall be A plus n minus 1, 3 minus 1, that gives us 2 times D, our third term. And also the seventh term, seventh shall be A plus n minus 1. 7 minus 1 is 6, multiplied by D. So these are terms, first, third, and seventh. But now when arranged in that order, they become consecutive terms in a GP. If they become consecutive terms, then it means we can realize a common ratio amongst them. We can realize a common ratio amongst them. So how do we work out that? We will say that in case we take this term, that is A plus 2D, and we divide by A, then we shall get the same as when we take this other term, A plus 6D out of A plus 2D. That is a very common analysis that we've been doing in our channel. The thinking applied there is, assuming that we have a term like 3, then the next one being 6, then the next one being 12. This is a geometric progression. And this implies that if it is a geometric progression, when we take 6 over 3, we should get the same as what we get after taking 12 over 6, which is 2. So common ratio must be existing between the 3 terms or amongst the 3 terms. So we take A plus 2D divided by A equals to A plus 6D divided by A plus 2D. After cross multiplication, what are we getting in this case? After cross multiplication, I shall have A plus 2D times A plus 2D, which means squared, equals to A into A plus 6D, that way. So now I can open brackets and have A squared plus 4AD plus 4D squared equals to A squared plus 6AD. Now at this point, we can group terms whereby A squared and A squared cancels out. Then 4D squared equals to 6AD minus 4, get 2AD. At this point now, we can say, we can simplify D. So 4D equals to 2 by A. 2 by A. What are we finding? Find the common difference. Find the common difference of the arithmetic progression. So how shall we remain with D? By taking 2a over 4, which means half the value of a equals to D. So the value of D can be given by half. The value of a has already been provided. The first term is 10. So the value of D is 5 that way. If the value of D has been obtained, then I think we can get the actual values now of the first term, the third term, and the sixth term. These terms now can be found. So the first term is 10, and the second one is 10 plus 2D. See, 10 plus 2D now means 10 plus 2, and D is 5. That gives us 20. The next term is A plus 6D. So 10 plus 6 into 5. That should be 10 plus 30, which is 40. Then the sequence now continues. That means if we take 20 over 10, we should get the same as 40 over 20. And this confirms the common ratio to be equal to 2. So the common ratio is 2. The common ratio is 2. We have gotten the common difference of the AP and the common ratio, the GP. Very simple working. Very simple working. At number 10, we are moving with speed. Ladies and gentlemen, remember consultation line 07 04 15 33 66. Please reach out for consultations and for revision materials. Number 10, the graph below shows the graph of height against time, maybe for plants or seedlings or anything. Height against time, we can see the graph. Then from there, what is the question? Use the graph to determine, correct one decimal place, the rate of change of height at t equals to 4. So when time is 4, what is the rate of change? What is the rate of change? Therefore, let me change my ink a little bit to something that can work with, this graph. At t equals to, this is the point. Because this is a graph, the rate of change is supposed to be gradient. But now that the graph is a curve, we can only talk about the gradient of the tangent, instantaneous rates of change, the gradient of a tangent at this particular point. So at that particular point, we can come up with a tangent. We can come up with a tangent. So we draw a tangent through that point. Let me draw the tangent very well. That way. Believe I'm very accurate. That way. Therefore, we need to come up with now just 2 coordinates along the tangent. So along this tangent, we can start with the first. For us to get gradient now, we need to talk about one of the coordinates is so exact, that is 410. Then we pick another coordinate along the same tangent. So we can pick a coordinate at this point, which is a 6. Time at 6, but for the heights, that is going to be 16, 17, 19, I think 18, yeah. 18, that way. So now with these 2 coordinates, we can get the gradient. The gradient shall be our rate of change. So the gradient shall be 18 minus 10 divided by 6 minus 4. So this is 8 out of 2. This is exactly 4. So the rate of change is 4. The rate of change is 4. So that is called instantaneous rate of change, whereby along a curve, because a curve doesn't have a uniform gradient, then what do we apply? We talk about at that particular instance, we talk about a tangent. So you draw a straight line just touching that point. That is why we drew a tangent at t equals to 4. So a tangent should be drawn touching the curve at that point. And from the tangent now we can get gradient. So that is it. All right. Another good question at number 11. Another very good question at number 11. What does number 11 tell us? 3 variables A, B, and C are such that A varies partly as the square of B and partly as the inverse of C. When B equals to 2, C equals to half, and A equals to 96, while when B equals to the root of 3, C equals to 2, and A equals to 46. Find A when B equals to 3 and C equals to 13. This is called partial variation. In partial variation, let it be known that we introduce 2 constants. So let's interpret now the first statement from English into mathematics, whereby we should say that A varies partly as the square of B. So A varies as the square of B and partly as the inverse of C. The other part is the inverse of C, that way. So if we introduce 2 constants at this point, then we shall have A, instead of the symbol of proportionality, now we use an equal sign with constants of proportionality. The first constant K to multiply B squared, and the other constant, small letter m, to multiply the reciprocal of C, that way. In this case, we should know that K and m are constants. K and m are constants. So again, let's check some more information. Just telling us when B equals to 2, C equals to half, and A equals to 96. So if we replace that, A equals to 96, so 96 equals to B equals to 2. So K times B squared, that is 4K plus, at the same time, C equals to half. C equals to half. So M divided by, M is being divided by half. M divided by half. You know, M over C, which is half, means 2M. Yeah. M divided by half. That is what it means. M divided by half. What about the second case? What about the second case? The second case says this. When B equals to root 3, C equals to 2, and A 46. So A 46, we start by replacing A 46 equals to K times B squared. So it becomes 3K. Because when you square root 3, it becomes 3. Plus M should be divided by 2. So that becomes M over 2. Yeah, C is 2. Unlike when C was a half. So dividing by a half now made it at 2. Yeah. So M over 2 that way. So you see now we are having 2 equations now. These equations, the first one and the second, should be solved now simultaneously. And to solve them simultaneously means, this means we shall talk about the value of M. From equation 1, the value of m equals to, we divide through by 2. 96 by 2 giving us 48. Then minus the 4k should also be divided by 2 to give us 2k. So from equation 1, the value of m equals to 48 minus 2k, which means equation 2 can be rewritten as 46 equals to 3k plus m over 2. So 48 minus 2k over 2. That way, this shall be 46 equals to 3k plus 24 minus k. See, 2k now equals to, when we take 46 and we subtract 24, I'm getting 22. So the value of k becomes 11. With the value of k as 11, the value of m shall be given as 48 minus 2 into 11. So m becomes 48 minus 22, which is 26. So we have the two constants now. That should imply that the specific equation now connecting all the variables, the three variables, shall be a equals to k, which is 11, multiplied by b squared, plus the value of m, which is 26, out of c. That way. So now we are having the specific equation. So we are advised to find a when the value of b is 3. So 11 by 3 squared plus 26 out of 13. So this is going to be 99 because of 11 multiplied by 9 after squaring the 3. Plus, what is 26 over 13? 2. So I'm getting the value of a is 101. A equals to 101. That is called partial variations. Partial variations. That way. Number 13. Number 12, sorry. Not 13. Number 12. Let's work out number 12 again, slowly and accurately. The position vectors of B is, the position vector B is 4i plus j minus 3k. And the vector AB is equal to 6i minus 3j plus 2k. Find to one decimal place the length of the position vector OA. Yeah, the length of the position vector OA. That means the magnitude of vector OA. We are supposed to know this, that vector AB is supposed to be given by the position of B minus the position of A. But remember, the position of A is not known. So how do we get the position of A? The position of A, to remain with A on the right, we shall have vector B minus vector AB, because the two of them are known. Vector AB has been provided and vector B has been provided. It is only vector OA which is not known. So vector A shall be, we take B, which is 4. I'm extracting the values. 1, -3, minus AB, which is 6, -3, 2. This shall be 4 minus 6, which is a -2, right? Then 1 minus a -3, which is 1 +3, giving us a 4. Okay. Then -3 minus 2, giving us a negative. 5. So from this now, we can say the position vector OA equals to negative 2i plus 4j minus 5 vector k 2. Yeah, minus 5 vector k. This is to mean that if we need the magnitude now of OA, which is expressed this way, we're supposed to talk about x squared plus 4 squared plus negative 5 squared. Then we take the square root that way. So the magnitude or the length of OA shall be, this is 4 plus 16 plus 25. Then we take the square root. The magnitude of OA shall be the square root of, that's 45. The square root of 45. We can't leave it as a surd because we've been told to 1 decimal place. Therefore, the square root of 45 now can be obtained. This gives us 6.708. So 6.708, that means 6.7 to 1 dp units. That's it. So now we are having the magnitude of the vector in question. Very simple. Look at number 13. The diagram below shows a model of a dog kennel in which AB equals to 15 centimeters, BC 8 centimeters, CH 12 centimeters, and HV 17 centimeters. Calculate the angle between ADV, that's a plane, and also the plane ABCD, correct to 2 decimal place. ADV and ABCD. ADV and ABCD. Those are the planes we are finding the angle between. So the plane that we are calling ADV is this one. Let me outline this particular plane from A to V, and also from V to D. V to D. Now you can see the plane so well. ADV, that is the plane now. A plane which is having a positive gradient that way, together with ABCD. You see now the two planes are meeting somewhere. The two planes are meeting somewhere. Let us look at the height of this particular model, the whole height of the particular model. The first thing that I shall be doing for us to get the height of the model shall be, I'm supposed to use remember FG is also 15, and also GH is also 8 that way. So with that, we should be able to use or to get the length F to H. The length from F to H. So the length from F to H is supposed to be 15 squared plus 8 squared, the square root. So 15 squared plus 8 squared, I'm getting the root of 289, which is 17. So I'm getting 17. So the whole length there is 17. So it should be known that if I use a half of 17, I'm drawing a perpendicular height there. If I use a half of 17, assuming this is point X, X to H is supposed to be, I divide this by 2, 8.5. So I can now use 8.5 and 17 for me to get Vx. So Vx is going to be 17 squared minus 8.5 squared. Then I take the square root. That is Pythagoras theorem. So Vx is going to be 17 squared minus 8.5 squared, then the square root. So 14.72 centimeters. 14.72. So Vx is 14.72. That means we can get the total height of the whole building. Total height of the whole building. So we can draw a line through the base that way. Such that if I continue dropping this height now to the base, if I talk of point, let me show you. If I talk of point O at this point, now I can see the total height VO equals to 14.72 plus 12, because from X to O is 12. This is going to be 26.72 centimeters. So with that height, and also from O to M, I'm labeling some parts randomly. This is point M. From O to M, that length is supposed to be, remember from A to B, that is 15. So it means this is 7.5 from O to M. So now we can get the angle between the base ABCD and ADV, the two planes now, because the two planes are meeting at AD. If the two planes are meeting at AD, then we need to realize the angle at the line where they meet. That angle shall be, I draw a line through the first plane, that is line VM, and also MO. So the angle now at that point, the angle at M, VMO, according to my labeling, VMO, that is the angle we need. So the angle VMO, which we can call theta, we shall say that. Remember, we have the total height, and we are also having the length from M to O. Therefore, we can say the tangent of that particular angle is equivalent to, we need the opposite length, which is 26.72, out of the adjacent length to that angle, 7.5. If that is the tangent, then for us to get the angle, we need the tan inverse of 26.72 out of 7.5. So this angle shall be equal to shift tan, I open my brackets, 26.72 divide by 7.5, I close brackets again. This is giving me 74.32. Yeah, 74.32. 74.32. Degrees, sorry, it's an angle. Degrees. So that is the angle. Well calculated. Number 14. This is from the knowledge of circles. We should be able to work it out. From the knowledge of circles, and we should be able to work it out. We are told that a circle cuts the line x equals to 1 at -1, 3, and also at -1, 7. It also cuts the line y equals to 3 at -7, 3, and -1, 3. Determine the equation of the circle in the form x squared plus y squared plus ax plus by plus c equals to 0 for 3 marks. The first thing that we're supposed to identify is the center of the circle, and also we're supposed to identify, apart from the center of the circle, we are supposed to identify the radius of this particular circle. You shall allow me to begin by doing a sketch of this information that we may analyze it so keenly. Yeah, we analyze it so keenly. So there are two lines here that we are talking about. X equals to -1. You know, line X equals to -1 passes through here. X equals to -1 passes through here. This is line X equals to -1, or we can reduce the margin. X equals to -1. That is line X equals to -1. X equals to -1. Where is the circle cutting it? At X equals to 3. At -1, 7. And also -1, 3. That way, the circle is cutting those points. Then again, there is another line called another line by the name y equals to 3. Line y equals to 3. Where shall it pass? At this point. Line y equals to 3. So where is the line x y equals to 3? So we are talking about line y equals to 3, whereby with this line we can now have at -7, 3, -7, 3, and also -1, 3. Yeah, -1, 3, that way. -1, 3 is already identified during the first. So this circle is passing through those points. The circle is passing now through those particular points. So we can sketch our circle, ladies and gentlemen. So the circle should pass here and continue to whatever point, but ensure it's passing through this this way. It's passing this way. Yeah, that is how the circle is behaving. Remember, we are just doing a sketch. That is to mean the first line is a tangent to the circle. And also, the second line, x equals to 1 and x, they are both tangents to the circle. So what is the middle part of the first line? The mid of the first line. From this coordinate, this is -7. So from -7 to -1, the middle part here, the middle part, -7 and -1, that means the middle part is -4. When we bisect that, we shall pass at -4. Then the other one, from +3 to 7, from +3 to 7, the middle part shall be, because this is 3 and this is 7. What is the middle part there? The units are 4, so the middle part is 5. The middle part is 5. So if we cut like that, we will be passing at 5 that way. So with this simple analysis, without having to draw on a graph, we are supposed to discover that then the center of this particular circle, the center O, shall be -4, 5. Center of the circle, -4, 5. We have the center of the circle already. It's -4, 5. Now that that is the center, what about the radius, which is again very sensitive? So from the center to any point now where the circle passes, because the circle is definitely passing through the points indicated there. So we can use the center and any of the above coordinates to know the radius. So it is passing through point -1, 3. With that, we can find radius. Can find radius by looking at the change in the two vectors, of course, the length of the two vectors. So assuming the point center is O, and the point here is the first point can be called Q. I'm just naming it for me to work with some vectors Q. So what is the vector OQ, which is our radius? The vector OQ shall be, we take Q, -1, 3, and we subtract -4, 5. So this shall be -1 plus 4, which is 3, and 3 minus 5, which is -2. That way. So the length of OQ, which is our radius, shall be 3 squared plus -2 squared. Then we take the square root of 9 plus 4, which is 13. So the radius equals to the square root of 13. The radius equals to the square root of 13. Square root of 13. So how do we find now the equation of the circle? We use the center and a point xy, which is unknown, along the circle. So we will say that when we take x minus the x coordinate, x minus the x coordinate of the center, then I square and I add y minus the y coordinate, which is a 5. I also square. I'm supposed to get the radius squared. Root 13 also squared. Yeah, root 13 squared. So because of this, now we can say x plus 4 squared equals to y minus 5 squared equals to 13, because root 13 squared becomes 13. All right. With this, ladies and gentlemen, with this, we should be able now to expand the equation and express it in the format which is displayed in number 14. So let's first expand. Expanding this gives us x squared plus 8x plus 16, then plus y squared minus 10y plus 25 equals to 13. So we rearrange to begin with x squared, followed by y squared, followed by 8x, followed by -10y. Then the constants now. The constants are positive 16 plus 25, then minus 13, because to the left-hand side, 13 becomes negative. That will be positive 28 now, equals to 0 that way. So we have the equation in the right format. Now number 15, a very good question from transformations and matrices. A plane figure of area 4 centimeters squared, 4 centimeters squared is transformed by a matrix which is 1, 3, 2, -3, and then by the matrix 2, -1, 0, 2. Find the area of the final image. I would like us to approach this one in two different methods. Because of space, allow me to start working out the space up there. I want to work out in two different approaches. So now we are talking about after transformation, we will have an image which is having some area. So from the matrix provided here, we can get the area of the first image by saying what will be determinant from the first transformation. The determinant shall be -3/1 minus 2/3, giving us -3 minus 6, which is a -9. So area scale factor from the first matrix shall be the absolute value of the determinant, which is 9. We know very well, listen to this, we know very well that when we take area of image divided by area of object, we're supposed to get area scale factor. And what is the area scale factor? The absolute value of the determinant. Therefore, a known area out of 4 should give us 9, which means this area of the first image equals to 36 square centimeters. Area of the first image equals to 36. Now, having area of 36 square centimeters, it is now getting further transformation by a second matrix. Further transformation by a second matrix, meaning that we're now going to say the second matrix of transformation will have a determinant. So determinant 2 now. The second determinant now is 2/2 minus -1/0. You see, we are getting 4. So the second determinant is a 4, which means when we take the last image or final image 2, out of the first image 1, we are supposed to get the second area scale factor, which is the determinant 2 now. So this area of image, which is not known, over 36, we should get 4. Therefore, to get y, the second image, we should take the product of 36 and 4, giving us 144 square centimeters. This is my first approach. My first approach of, from the first determinant, we get the first area scale factor. So the first image during these transformations, these are called successive transformations. So the first image takes an area of 36. Then now it is further transformed, whereby the second determinant is a 4, meaning that the second area scale factor is a 4. Therefore, the last image or the final image over the first image, which is 36, should give us 4. And therefore, the final image can be found to be having area of 144. Now we can also talk about this successive transformations, whereby now I'll go to method 2. Method 2 says, according to my intelligence now, when we have successive transformations such that we have the first matrix, we can call it T. The second matrix here, we can call it M. Now, T was performed first, then M. Then the successive transformations should be written as MT. MT means T was performed first, then M later. Therefore, we can get one matrix of transformation which can represent the two matrices there by taking the product according to how the matrices have been written. Therefore, empty means we start with M, 2, -1, 0, 2, followed by 1, 3, 2, -3. From this, understand that this is what was performed first, then later this one. But in the writing, we begin by the one which was performed last. So when we get the product of the two matrices, we will have gotten one matrix that represents the two of them during a transformation. Therefore, we take row times column, whereby 2 by 1 and -2. 2 times 1, -1 times 2. So that is 2 minus 2, which is a 0. We proceed. The same row by the second column. 2 by 3 and -1 by -3. That becomes 6 and a +3, giving us 9. Then we go to the second row here and the first column. 0 by 1 and 2 by 2. That gives us 0 plus 4, which is a 4. Then finally, we are talking about 0 by 3 and -2 by -6. This becomes 0 plus -6, and we have a -6 here. So this now, one matrix, can represent the two successive matrices up there. And therefore, we can talk about just one determinant. So what is the determinant here? Determinant of the one matrix representing the two shall be 0 by -6 minus 4 by 9. See, now we are getting 0 minus 36, which is a -36. With the -36 as the determinant, we shall conclude that area scale factor equals to absolute value of determinant, 36. Absolute value of determinant, 36. So the final image out of the first image should give us 36, which is our area scale factor. So how do we get this final image? 4 by 36, giving us 144 square centimeters. So we are through with question 15. Very well executed. Then we'll be talking about number 16, which is a question on statistics 2. Remember, this is paper 2, whereby statistics is very crucial, because if it is statistics 1, it shall appear in paper 1. Statistics 2 shall appear in paper 2. It is not possible to have a KCSE exam without statistics. It is nearly impossible. Actually, it is not a surprise to have statistics appearing in both paper 1 and also paper 2. The data below shows the age of 10 students picked at random in a secondary school. 6, 11, 13, 14, 8, 7, 12, 20, P and 9. If the sum of f of x squared equals to 1360, determine the value of P, hence find the standard deviation to 3 decimal places. So each factor here, or each number here, each value of x is appearing once. So we have general frequency of 1 for every value. So f is 1. So 6 squared times 1, 11 squared times 1, 13 squared times 1, 14 squared times 1, 8 squared times 1, 7 squared times 1, 12 squared plus 20 squared plus P squared plus 9 squared should give us 1360. So how shall we remain with P squared? When we add all this, we are getting 1260 plus P squared equals to 1360. Therefore, P equals to 100, then the square root, and that will give us 10, or P squared equals to 100 implying that the value of P equals to 10. So the age of the 10th student is 10. Then now we proceed to say that, how do we get variance? For us to get variance, we're supposed to get the mean score first. So what is the mean age? Mean age is going to be all the values added. 6 plus 11 plus 13 plus 14 plus 8 plus 7 plus 12 plus 20 plus 10, because P has been known now, plus 9. Then we divide everything by 10. We divide everything by 10. Everything over 10. See, we're getting 110 over 10. So we have 11 as the mean age. So for us to proceed now to standard deviation, we're supposed to first work out what we call variance. So I'm talking about deviations first. Deviation is every value minus the mean. How is each value differing with the mean? So all the deviations now can be tabled here. All the deviations should be tabled here. So we talk about 6 minus mean, -5. 11 minus 11, 0. 13 minus mean, 2. 14 minus mean, 3. 8 minus mean, -3. 7 minus mean, -4. 12 minus mean, we get 1. 20 minus mean of 11, we get 9. Like that. We continue listing all of them. 10 minus mean, 10 minus mean of 11, -1. Then finally, 9 minus 11, we get 2. So those are the deviations. Those are the deviations. Let me confirm whether they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 deviations, yeah, that way. 10 deviations. 10 deviations. With all the deviations now, we're supposed to say that for us to get variance, S squared, we take the summation of all the deviations squared out of the total. Let me charge my pen. This is out of the total population, the total number of figures that we're working out with. We're working out with 10. So I'm supposed now to take all the deviations squared. 5 squared, which is 25, all of them. 25 plus 0 plus 4 plus 9 plus 9 once again, plus 16 plus 1 after squaring 1, plus 81 after squaring 9, plus 1 after squaring -1, then plus 4 after squaring 2. So when I add up, I'm getting 150. Then I have to divide all that by 10. So everything over 10. You see, I'm getting 150 over 10, which is 15. Now, 15 is variance. If 15 is variance, ladies and gentlemen, I can talk about S. S is now the standard deviation. How do we get standard deviation? Standard deviation is given by the square root of variance. So the square root of 15. And according to instructions, we are told to 3 decimal places, which is 3.873. So this is now our standard deviation, the square root of variance. So we have everything in that particular question. That is the paper, that is the section 1. Remember to subscribe, remember to share with friends so that we may invite them to our programs. Even after we've gone through it, you are in a position to still find the same presentation here. So you are free to come again later. Remember our August programs. The number is already displayed here. Please reach out for more. Thank you so much. See you next time for a section 2.